Welcome, both Americas. Good morning. Welcome, Europe. Good evening. And welcome, Asia. Good evening as well. So, or maybe even late night. We continue with our series of webinars about 1 hour about KNFT automation profiles, device profiles, supporting Canopen interface. Today, we are talking about 402 profile, drives and motion control. For those who are familiar with that and know a little bit about Canopen, it is not that much new, but for the other ones, I will introduce today what is new in 402 device profiles comparing to what we have done last years. For those who don't know about me, about KNFT automation, I will do a brief introduction of the company. My name is Oskar Kaplun, and I will lead you through today's short update on 402 profile and what is going on in KNFT automation in general. I'm an engineer working about 10, 12 years at KNFT automation. I'm doing technical secretary stuff, supervising various working groups, developing specifications such as I/O modules, Canopen Lift, and also 402 special interest group drives and motion control, among many others. Besides that, I'm also test engineer at KNFT automation, test Canopen devices, and now also KNFT devices. For today's content, a brief introduction of the company, and I will talk about general for the new to 402 profile, Canopen drives, what does it do, where do you start, what do you need to know about this, and what is it all about. The next one would be also a brief introduction into new technology, also CAN-based, but a new KNFT, and it's called Canopen FT, flexible data rates. We'll see about this later. We have also updated more or less our specification for drives, which now can Canopen FT as well. And finally, I would introduce a brief example of driver motion control application, what you can do with that. The example is very small and relatively easy to understand, but there could be many more of that kind. I don't have so much time for that, but for one example, I think that would be worth your time. Well, KNFT automation was founded at the times when automotive industry welcomed CAN as a new field path, very useful, very effective. And even then times, 10 years after development in 1992, the people found out that, yes, automotive has the knowledge about this, but now the industrial automation, embedded engineering, embedded automation is quite interesting features of CAN. I would like to know about this more. So that will be difficult. That was difficult at that time to contact automotive and ask them for offer services. Beside the case, they have their own projects. So people joined together and said, well, we would like to have an open manufacturer group that supports users of CAN development and of CAN usage, whatever it might be, either industrial automation, aerospace engineering, whatever it might be, whenever CAN can be used. So CAN Automation was founded. On the other hand, there was interested to promote technology also in various markets. On the other hand, there was idea to provide technical information database for starting of the development. So CAN Automation, located over the course of 25 years, plus a couple more years, we celebrated our 25 anniversary, actually 25th anniversary of CAN itself, and soon we will celebrate anniversary of CAN Automation. The point is that CAN Automation was founded by only several people. We were talking about that as well. And it's located currently in Nuremberg, in Germany. You can contact us using either phone, if you call us within Germany or Europe. But if it's too far for you, you can just contact us by email. Over the course of years, we're located throughout Europe, throughout of Germany, throughout a neighborhood of Nuremberg. We had a subsidiary companies, more or less, in India and even China, but now they are not longer available. So if you want to contact us straight at CAN Automation office in Nuremberg. CAN Automation was founded to be financed by membership. So it could be able then provide by this means all the necessary support for the members who pay annually fee and offering some various services to them. Over the course of years, it started with only 16 members and grown up to 703 in this year. This actually doesn't mean from this diagram, is not recognizable from this diagram, either interest in CAN in general on a specific technology as Canopen or specific device profile or application profile we designed. So it is basically to say CAN-based technology are still on hold, on site, and are still in favor of various manufacturers. So back to the history, as I said, there are only CAN Automation was founded only by a handful of people. One's hand, it was Mr. Holger Zettwanger, who is still the managing director of CAN Automation. And the companies like Berghoff, LP Electronic, MEN Technology, and so on, they are still our members for that long time. In the course of the year, we had started with promoting CAN-based technologies on various markets, various exhibitions. We have designed specifications of every possible reason on behalf of our members. We had also technology transfer and information about how and what is CAN, what are new technologies within CAN, what CAN allows to do on our biannually International CAN Conference. The latest one was held, postponed due to COVID. It was held in this year, this summer, and introduced the third CAN-based protocol developed by Robert Bosch GmbH. Since you know, CAN was developed by Bosch, and there is a third generation of CAN called CAN Excel is currently in the development. Let's say over the course of these 20 years, about so, we had various activities, and we're continually developing CAN-based technology, especially application layers like Canopen, and KNFT as of right now, and a third generation of CAN-based protocols. We provide information on various exhibitions, organize various conferences, promote products, and finally, we design specification as well for various application fields. The commonality is then Canopen or KNFT interface of theirs. CAN Automation as an organization just is paid by members, but it has its company subsidiary where I'm working at, and this company subsidiary fulfills the requests of CAN Automation organization. So the organization is consisting of two arms, the technical and financial arm. The technical arm is, as here in this slide introduced, is actually where we're developing specification, various application fields for CAN-based interfaces. There is a committee which supervises which directions we are going technically, which new developments of specification or application device profiles, whatever it might be with CAN-based interface, which direction we go, and our members actually define where we go with that. This is technical committee, and we have several subcommittees which work on various specification development. Today we are talking about drive and motion control profiles. So we say this is a profile subgroup, and within it, the special interest group drives and motion control in this slide is marked with a bold script. So beside that, we have various many others. We have ordered them in a very specific form, like all profiles, like specific device kind specification, we are assigning to the profile groups. Then we have development of two independent technologies, Canopen and KNFT separately. This means actually Canopen technology has a base profile, base communication profile, base functionality protocols, and there are advanced protocols which are specified on under the supervision of the Canopen working group. On the other hand, having a new KNFT working group, we have plenty of development of this based and advanced protocols for Canopen. Since there is also interest from our members to the J9039 technology, we also follow this path as well, and we have several working groups work in a close cooperation with CiA organization in the US, which actually maintains J9039 protocol and various specification there, and we provide our recommendations and support them in development of Canopen related technologies within J9039. Since it's also CAN-based technology, also we follow the KNFT and CANXL new generation of CAN-based protocols and how they will be developed under J9039. Besides that, we separated also the development of specification, technical direction for lower layers, let's say ISO OC physical layer for transceiver recommendations, for physical layer recommendations, as well as for data link such as CAN, CANFT, and CANXL. There are separate groups. There are several subgroups, and we're developing about 20 or so specifications alone for that case, alone for the lower layer subgroups. There is, of course, growing interest in safety and security as you say, to the far right corner of the slide, we have several working groups, already several working drafts we're working on that. And beside that, we have also high availability for such redundancy concept throughout every Canopen specification. In total, we have about 50 or more profiles on Canopen alone, which will be also KNFT as well, and various other things. And this is what we do from a technical side. On the other hand, we have requests of our members to promote their products, to promote the markets, to promote CAN-based technologies in various markets. So we design publications in various languages, search for exhibitions, conferences where I can participate and promote the technology itself on behalf of our members. And on exhibitions, we could promote products, partially products of our members who would like to exhibit them, and provide some demonstrators for newly developed technologies like KNFT, KNFT, and soon it will be also CanExcel. So the services, service of ours is actually developing the specification, promoting CAN-based technologies. This only way to do so that we have something reliable, collecting some requirements, which markets would request, would need certain technologies, would require certain devices, and so on. For that reason, the requirements have to be put in a form of specification. And finally, at the end, they have to provide a universal interface to communicate between the devices. The reason for specification is actually we design it for the end user, which will be a system design. And the specification are also designed from this point of view. So there is, of course, device manufacturer who know how to do that, and they know now for whom. And specification itself is designed for system integrators from their point of view. And device manufacturer knows what to design for them by this means. We're offering, of course, for these four groups of developers and users, device manufacturers, system designers, marketing people, and developers who would like to know is in deep. These four directions. For device manufacturer, we have providing conformance testing that you could test the devices they are developing. We also offer for system designers consulting how to work, how to configure your device based on the specification as far as it's possible, how to do so. On the other hand, there is marketing, which would like to know how to promote the device. Is there a possibility to have some kind of guideline or guide for product guide or something like this, where they could offer, put their advertisements and so on. This is what we do as well. We design also brochures for different markets where the special market are addressed, which devices are included in this market, which applications are mostly promoted in there. It is all on behalf of our members. Beside this case, we also promote information, what is new at CAN Automation, such as what new specifications, new technology are emerging in there from us and our interested parties, and whenever and whoever would like to know about this, came to us and know about this. And more than this, we go by ourselves to various industry conferences, exhibitions, and international CAN conference, and promote actively about this knowledge, not only about specification, but CAN-based technology, what is new in there, what is helping. We're offering as kind of technical staff webinars, seminars, tech days, and so on. Webinars only for 1 hour, just to make a short introduction for you in this new technology, how you can work with that, what you can do with this, how does it help you. The seminar is more in-depth knowledge, where to start, what should I prepare yourself to, and how to do things more in details. And finally, we have a tech days, so-called technical days, where we promote a very specific topic in details and pick people from industry who would like to introduce their side of view on a very specific technology, CAN-based technology. You can find, by the way, all this information on webinars, seminars, tech days, marketing opportunities, product guides, consulting services, and so on. All around our services, you can find us this on our website. Besides that, we actively promote information, what is going on for members and non-members. You can subscribe for these email services and receive very actual information on what is happening in the world of CAN, at CAN in automation itself, and what and how you could get advantage of this. Website provides, as I said, various information on our services, and also briefly a knowledge base. What is CAN? What is Canopen? What is KNFT? What are new technologies? All these questions you can find mostly on our website. If not, then we are proud to answer your question if you contact us directly by our email. Finally, if you see that you would like to design your device, there are certain benefits you could have if you become CAN Automation member, such as free of charge vendor identification, free of charge access to specification of every kind, even working drafts, and so on. And you have, most importantly, effect on the development at a very specific device profile and application profile. You could bring your requirements into this one if you actually want it. So I leave it to check out the benefits in general. And then finally, I'm going to in-depth to our webinar of today. Today's series, I represent 402 profile. This is actually not in-depth information about 402, but more of the actual version and new updates in this profile for those who know a bit, maybe worked already on 402 and would like to know what is new about this. I'm starting then with classic Canopen drives and motion profile. This is what you have to know. We call now Canopen, classic Canopen, as a classic CAN, because there are in general 3 technologies, CAN-based technology available on the market. Well, 2 surely available, the 3rd is emerging. Thus, available is CAN and KNFT, and emerging is CAN-XL. We will not talk about the later one. Would welcome you to attend our other webinars on this topic. What we'll talk about today about CAN and KNFT-based Canopen, let's say, and what is going on with 402 in relation to those, and what are the new 402 features that you have not known about. So you will start, of course, with asking, yeah, where do I start with developing? I need a kind of requirement. So is there a specification? Yes, there is a specification, and CAN Automation developed it. It's about 15 years old, But note this, it has already fourth version. And this fourth version, there are two at the version 2, where we started, where we moved this on and standardized this in real standard, since the specification is just a specification. Real standard IEC 6158-7, and it is available already in the second version. So just to know, the version of Canopen you use now, version 4.0, is actually corresponds exactly to the second version of IEC standardized profile. So the standard is, of course, preferable to implement, but for our members, we still develop this specification further, and we work in close cooperation with the international standardization, with IEC committee, to introduce the new features of 402 into the next version of the standard. Well, what about the specification? It has several parts. Part 1, 2, and 3 is already in standard, in the second version of the standard. Part 4 and 5 are outside of the standard. This is very specific functionality, which is available for our members. And since it's not standardized, it can be continued to develop and released as the specification for implementation. For our members, we could only release even part 1 to 3, but in a version as a draft specification proposal. You can implement it, but it still remains as a proposal. Once it reaches the states in standardization, so it becomes again standardized in the third version of the standard, then you could take the standard if you see that the specification is not wide enough for you to implement. So there is not much changed ever since in there, since we are keeping up on the migration path between the specification and backwards compatibility is the main point of this one. The PDO mapping is remained the same, but it is slightly changed in a very recent version, which I'm talking about later. Just to know, if you want to participate in a working group, want to bring your requirements, you're welcome to participate in a special interest group at CAN Automation, Drives and Motion Control. For that one, you have to be CAN Automation member. So, Canopen version of the profile. What is this? For those of you who are new to this concept, our goal and reason is to design the specifications, but not because of the specification, but more of the standardization of data interface to create unification of the data interface till a certain degree, till the devices developed by this means are becoming interoperable. For this reason, we have 3 degrees of standardization at CAN Automation. You can design your drive profile very generic, based on 301 specification with only basic Canopen functionality. This one will be barely standardized data interface, since 301 is common to all Canopen devices. So you have, if you design your drive profile on this, based on the 301, then it could be only one in the world. So compatibility, backwards compatibility, and compatibility to other manufacturers is not given. There is the next degree, device profile. So for the very certain device kinds, we specify very certain data interface, an application data, which applies only to this device. Like, for example, drive profile, there will be position, target position, configuration of set points, position set points for the closed loop controllers, such things like this. Interpolation database parameters, that is only used actually and standardized only for drives. So the acceptance of such a profile from the standardization point of view is much higher than a generic one. So, and 402 is this specific kind, is this device profile. The third degree is actually application profile, which you may see on this slide, where instead of each single devices I have here, I have the whole system, and I have completely configured devices, means from point of view of process data, they are also completely configured. All these CAN IDs in my network, completely configured. That will be an application profile. 402 allows you modular creation of such application profiles based on your needs, but there is no standardized application profile for 402 because there could be various drive constellations which you bind together, devices, and configure it upon your wish. And our members didn't wish to define a 402 application profile. So it should be left some degree of flexibility that every manufacturer, every system designer designs his system if he needs some drives based on his own. Still, the data interface is very standardized. There are certain parameters which only belong to drive profiles. There are no such parameters for other Canopen device profiles, and thus allows you also using video mapping with this data, creating devices which you could just simply and easily configure in one specific network. That is what the device profile is for. How do you know about this data? What is actually in there? What does it actually mean? Device profiles in detail as standardized data interface. What is actually, what does it actually mean? So we have, first of all, we say we have a parameter. As you know from Canopen, there are parameters defined in Canopen Object Dictionary, and they are defined as references to this parts of the memory, and they code indexes, and each index has 255 sub-indexes. Totally, there are 16-bit in total value, 16-bit sub-index. This is about 65,000 indexes available, 65,535 or something for your disposal. From those, they can open, if you know from Canopen, if you remember from Canopen, if you know this from 301, there is a range of indexes reserved for the application itself. From index 6000 to index 6007 FF hexadecimal. This application profile. Within this application profile, every Canopen application profile may have its own parameters for this specific kind of device. The same applies for drive profiles. So you know there you find only drive profile specific data. Besides that, Object 1000 as a mandatory one provides the information about the device, and every system designer who reads this data back from each drive he purchased and want to integrate in his system knows about device type, device content, and from the parameter 1018, which is vendor ID, he knows to whom belongs this device. Another thing, the object 1029, which is listed here, provides the standardized error behavior and error codes, which are also given basic for every Canopen device profile. But in case of drive profile, we specified exactly cases for drive errors. Is it drive in error, magnets not under current? Is the position not reached? Such kind of errors are specifically provided in the profile. And beside of this, the heart of this whole stuff, they are process data, video communication mapping parameters. They could be very generic, but in this case, for 402 profile, they are very specific. There are several kinds of several mapping proposals, default mappings, which you could support depending on your needs. There is no need, there is no necessary to have only one, but you could select by yourself depending on your drive kind, what you can do with that. So again, also the standardized application data only for drive makes this kind of unique. So basically you may even find the very same every device, every 402 device throughout the world has the very same data, especially if they are mandatory in standardized application parameters. So inverter, 402 inverter will always have their mandatory set points. And this is a good thing, so you don't need to design every time new software to operating your drive, but you could design the integration of generic software which handles 402 parameters, 402 configuration and operation, and you could use it with almost every Canopen 402 device on the market. So there are, of course, specifics if you have between inverters and stepper motors and so on. There might be some diversities between the software tools using there, but the commonality is actually the configuration of the devices. It is then very close, and there are several tools which allow you to do so available on the market. Some companies provide their PLCs which could be able to configure the 402 devices. So then we talk about those green marked things in details. So far we have a time for that. Object 1000 gives you information about device type, about the number of specifications. Every device profile has this in lower 16 bits. The upper 16 bits are reserved for specific information, which in this case describes what modes are supported by 402 device, and a few bits inform what kind of the type. We have introduced, for simplicity, very few types of drives which are actually available. There will be a frequency inverter, there will be stepper motor, generic drive, and so on. Mode bits, on the other hand, can be managed manufacturer specifically, but the very important thing, if you design that you put closely to that of specification, so that your customers would not be overwhelmed with that and would just consult the specification for 402 you could always find this data inside. In the next couple of slides, I would introduce several key features or properties of 402, which are important. I have mentioned them maybe partially already, but we'll go through them in there. So for you to know what, if you started with that, what is that in there for you? So as I mentioned, it is internationally standardized, so you don't need to be a CAN automation member. You can just purchase standard, purchase vendor ID, start your development. But on the other hand, you are not in a development in knowing of what is new, what are further development of the specification itself. For that reason, you have to become a CAN automation member. Canopen drive profiles, among the others, are mostly used and implemented throughout the world. There are many companies in various application fields supporting Canopen interface in their drives. Either it is visible or it is deeply embedded. Drive profile is designed for only few mostly used types of drives, such as frequency inverters, stepper motors, and server controllers, or shortly servers. And that is making that profile very attractive for most used application you would like to design on that. The footprint of the software is also relatively small. You can design about, but also many features, many Canopen features, and many specific drive related features in there. It is up to you. There are several manufacturers of PLCs, SNC control devices, which support Canopen interfaces and support configuration of 402 applications and drives. We have distinct device state machine with transitions, allowing you to fully implement the state machine, the operation, the process state machine. It is also independent from Canopen communication state machine. So the drive state machine has the only drive specific features that you could find if you look into the specification. You're welcome to ask us how to go on that. There is, as I mentioned already, some error codes defined, and it is allowed actually fully blown error diagnostics based on alone on Canopen error detection and error state machine. There are many application modes defined, but we're not finished. We continue to develop specification further with new functionality, new modes, and new profiles. A new additional extension for the profile. The PTO is standardized, and it applies for every types of the device. There are different, slightly different, but mostly closely bind a process data in there. We're looking into this within the next slide. PDO mapping is generic. So you define, it is especially a PDO, default PDO mapping is generic. It is also type specific for stepper motor, frequency inverter, and server drive, but you may have define your own manufacturer specific additionally to that. So by default PDO mapping is generic. The application parameter, which is most important thing, is only for drive profiles. Is available to everybody who has access to the specification, and a very certain configuration requirements for drive profile and so on. And application functions are defined very similar in many drive devices around the world. As long as you want to have distinguish or add your specific functionality, which is not available in other drives, for you manufacture specific range of parameters is also available. So this all functionality is there. But the generic application functionality of 402 is available to everybody. Most of devices supporting them. They are identical in how they support them. Finally, to the update, what do we have actually here? We have introduced read-only 64 actual value position, but we planned to fully blown 64-bit implementation for the drives. That will not be done in the next version, but the version over the next one. That would be also possible if you use Canopen technology, we're talking about later, that there is more advanced diagnostic possibilities emerging in there, more than you could imagine with standardized CAM. Of course, we have several new application modes or operation modes introduced, mostly to the existing mode extensions and so on, but in details you can find out in the specification. We're not, due to the limited time for today's presentation, we will not have to talk into this in deep. Just limit this to that they are existing, and you're welcome to look into the specification. PDO mapping is adjusted, and it is available also for this only actual position of 64-bit as well additionally. The new function we introduced is precise positioning of the drive for using camshaft. And astoundingly, this abbreviation CAM also applies for the cameras, which monitor the movement of the drive. And the drives, the cameras also calls CAM. So do not interchange that, do not mix them together. It's about a camshaft, but the camera could be mounted on a drive and fix and detect the position on there as well. So we're currently in the development of this precise drive positioning. In the next version of the specification available for our members, it will be as a standalone function available for every manufacturer. Well, briefly about default PDO mapping. We have it. What is PDO mapping? This is process data. I transmit some target position, status word of my drive from the PLC into the drive itself, and drive moves the motor, gives the command to the motor to move to a certain position and collects the data from the encoder where the motor is currently located, where the shaft of the motor is currently located, such things. These are exchanged over the CAN bus, and we call it PDO mapping. We transmit in a very specific Canopen protocol called process data object. And the standardized is default PDO mapping. It's just an example for node ID1 with PDO mapping assignment for those two mappings we have. We define PDO in a device from the point of view This PDO is transmitted by the device sends its status, or the device receives PDO and receives, for example, in this case, control word that will be, for example, controller or even drive, who knows what to do next and give the next command to the motor if it hangs on a separate CAN interface, and so on. Beside that, beside only status and control word and correspondingly transmission and reception, we have designed default PDOs where you give also further information such as actual position value, where to drive to, or the target position if we receive command to move to the certain position. So standardized default PDO mapping means every device which delivered unconfigured provides all this data. And basically this simplifies configuration of the device. If you say, okay, I do have node ID, I don't need to change it whatsoever, and default PDO mapping is sufficient also for me, you basically can have your device. What you need to know is actually to find out the station which collects all this data your devices, such as in this slide, A, B, and C, would like to send. On the other hand, you have to transmit some data, some control commands to this drive, such as TPDO5 on the PLC picture on the side. And they have this PDO5 named in each drives A, B, and C as RPDO1. So this is basic concept of configuration of the devices in the network. The device is producing and consuming data over the network. And in this case, I have marked this with the colors, but you should know that PDO is going across the network. From the point of view of the bus itself, there is no transmit or receive PDO. It's always a PDOs, process data transmitted, CAN messages. But in device itself, they are known, configured as is usually done with a CAN with this message filtering. So similar, it is done, there is a transmit PDO, is PDO that the device, specific device transmits. And receive PDO is the device which is received by this device. Please bear in mind that PDO numbers, TPDO, RPDO numbers may vary between the devices. And since we do not define PDOs, receive or transmit PDOs of the opposite side, such as represented here in the picture on the both on PLC, it is what you should design as a system designer in your PLC, where to the opposite side collects the data or transmits to those drives. We define TPDO and RPDO in the specification 402 only for the drive devices. So this is a basic concept, how we exchange the data, more on Canopen, how it is configured, how you can configure your network with plenty of devices. Now it is the point that you would like to test your device. Since when you have implemented it in a very early stage, you could use our conformance test tool, test Canopen implementation. However, we do not test the 402 profile. Sorry, we have here also my mistake, 401 device testing. This is the wrong number. I would fix it in slides as well. But this is basically, we test 301 as basic Canopen functionality in all drive device profiles, drive including. So we cannot test it, but it is very helpful to know what is actually of Canopen inside of your drive profile. So please bear in mind that it is not necessary to bring this to certification to us. It is still free of it is still free free decision of yours. It is not free of charge, of course, depending on costs. This is a little bit cheaper for our members, but Canopen is not mandatory. Canopen conformance is not mandatory. The second interesting thing, once you have tested the device, you would like to see how does it behave in a real application. Maybe you get a PLC or CNC from your host controller manufacturer. You could test your devices with several other devices together and check this out. There will be a kind of interoperability testing. We offer to limited extent also in a past PlugFest where we have this interoperability. We invited a manufacturer of various companies, including also PLC manufacturers. So we connect all devices and see how their drive profiles manage in a real network. In a pandemic time, we had limited this interaction, but once it is over, we hope to continue with this one, and you're welcome to participate in this one. Then I will briefly go through the Canopen KNFT. This is new emerging technology. KNFT was introduced in 2013 and released for standardization 2015. There is a standard IC, ISO 11898-1 and 2, standardized 2015 and 16 correspondingly. One is a CAN-based formats, data link layer, and the second is the one and the same one standard for all physical layer implementations. A physical layer standard. Well, the interesting thing is that now in the standard CAN and Canopen and KNFT that are together in there, so you have to look very closely which one you would like to have, which controller. But you don't, since you don't, if you do not develop the controller itself, a transceiver, you don't need specification. You just need to know what kind of the device or what kind of controllers you need to purchase and what features they have to have based on the standard, for example. So KNFT offers some certain obvious advantages. Biggest is the payload of 64 bytes. 8 times bigger than a CAN. It is, however, slightly limited for error-free communication to 4 or 5 for the moment megabit, but the transmission of the data occurs in a data field only. So in contrary, as you can see for both frame formats, a classic CAN and a KNFT based frame format, the green marked field is where the bit rate can be switched to the higher, and to reach this higher payload and higher speed of this transmission, Robert Bosch said, no company developing that said, and there is no need to maintain the same detection mechanism of each bit, which limits effectively my speed, but say within a data transmission, there is no need to do so. It can be transmitted with the highest speed supported by the CAN transceiver. So by this means, it could be up to 100 megabit if the transceiver supports this functionality. There are some nasty effects, side effects, physical effects occurring because of it. So we had to fix certain issues developing. There are companies developing various methods to reduce parasitic effects of the higher speed in this case. And for KNFT, for the moment, there are maximum speed is 4 megabit to 5 megabit. However, in the arbitration phase, where you can select between those frames, you still operate on a way the CAN does, so up to 1 megabit. And still in this arbitration phase, at the beginning, at the end, where I do have my acknowledgement and end the frame, we operate with the principle of CAN transmission, based CAN transmission, classic CAN transmission, bit detection. So the bit sent is also bit received, which limits our length of our system, of our network, but they are only short bursts of data. There is no need to be curious about this. Most important is that data transmission phase could be done with a much higher speed. So far about KNFT features, it has, of course, impact on higher higher layer application layers, such as Canopen, and thus we introduced Canopen FD, where we replaced STO services with new universal STO services, offering various advanced features in there, such as I do use only client node ID. No, I use only node ID in the configuration itself of each transmitter. The client uses its node ID to provide the message to the server, and USTO server uses its node ID to provide a message to the client. This is in contrary to what was designed in Canopen, in classic Canopen, and was required to completely design the pairs of this communication for STO communication. In universal USTO, you don't need to do so. There are some interesting key features in there. We're coming why we need this in 402 later on. So this is confirmed data transfer in unicast, as it was also in classic Canopen, was point-to-point. This is unicast, but USTO goes beyond this. You could transmit this to many, multicast and broadcast. This opens completely new opportunities, even for drive profiles. There is also maintained short data transfer and such long like string and firmware transfer, such as segmented and bulk transfer. There is possible to assign several consequent or independent accesses to the very same, from one same client to the very same USTO server. There is a routing capability allowing you to create routing within the network, not outside the network, but within the network, to create a network within Canopen network, and some other key features. You're welcome to look into this in specification 1301. So by USTO, you can control all the information you need is inside of the frame. Since we have a larger payload, 64 bytes, what does only few more bytes, spend few more bytes for control information means in compared with a vast number of application data with only one frame. And we do so. We encode destination address, since CAN ID only knows node ID of the sender. So we know actually in this case that where there is message to address it. And the second one, we have also command specifier. It is slightly different as we have it in classic Canopen, but now it covers all information needed to know what kind of the USTO transfer is that, then the session ID field allows you to indicate which message from which client to which server was sent. And as we said, this parallel access, there could be several session IDs. So several parallel access to the several devices, same device, but we can distinguish with those requests, different requests. Besides appendix, index, and so on, we have introduced also data and size, and we still have plenty of application data within only one frame. Of course, for firmware update, there will be much larger frames, but we have also a limit response to the 6 bytes back. If you remember, the classic STO has a limited and unchanged size of the frame. Is always 8 byte, either the send or reception or confirmation. In a USTO, we can reduce the traffic down to the 6 byte of this correspondence confirmation analysis. The USTO routing, there is a capability to access the very same network, maybe different networks around this. You're welcome to look into that in 1301 in this case. And finally, we go to the Canopen FT technology applied for 402. As of right now, we have already a second version actually of this Canopen FT in there. They're working independently. So there is a Canopen based 402 and Canopen FT part in there. If you have Canopen FT, then you know there is no STO, there are no some other features, and the other things remain in there, but you have to use USTO in there. Since it is not that much distinguished, the application parameter, the main throughout CAN-based technology is the same. So Canopen or Canopen FT, they remain the same. The only different thing is their PDO mapping. And this is the only thing that's changed, and we keep it in backwards compatible. We'll look into that in the next. This specification is actually further developed by the very same special interest group, drives and motion control, which I'm supervising. And Canopen FT PDO mapping is specified in part 6. Soon we released the new version, but as you can see, we have default PDO mapping already mentioned in there. In case of PDO mapping for Canopen devices, we keep, despite of the higher payload, we still keep the backwards compatibility. So the number of bytes, the number of process data, it does not extend over the 8 bytes. However, there will be soon possible changes, possible new mapping available, which utilize the full extent of higher Canopen FT payload in this case. So I have certain advantages which we see in an application example in there, what we can do. For now, I would just limit this to the very same information about testing. If you develop also Canopen FT and you're interested to develop this one, we don't have yet conformance test tool, but we do already conformance testing. We have the conformance testing procedure. So we're still on work, on hold, in progress with development of the test plan specification. To overcome this limitation, we introduced test procedure, which we started already since this year. And we will offer also interoperability opportunities for testing your Canopen FT drives. So, and finally, we have an example. If I summarize these all things, so we have a drive profiles. There are also two technologies, Canopen and KNFT. You can choose, pick one which you start with. You know which specifications you have to look into, and also maybe you could, if you want to use the standard for that reason. There is an example of the medical facility, or maybe is rather a laboratory, more similar laboratory environment. We have 3 drives, each drive for each single axis, and also a kind of injector, as medical injector or whatever, laboratory injector, whatever reason it is. So the drive profiles are assigned to the logical devices like this in a figure to I could control completely independent all 3 drives, all 3 axes. And additionally, I can control also the injector movement. Either this is just another special axis, and I could bring them all to operate together in my application. The reason is this modularity and usage of the logical devices within Canopen and also KNFT. This means every KNFT can has up to 8 instances of the very same device inside, just to control its functionality depending on its reason. The PDO mapping for this case will look like this. I have 4 PDOs, 3 for each single axis. This mapping is actually for classic Canopen. As you can see, I have status word, actual position as standardized default mapping, even for axis X, and the same for the various axes. And as you see, the number of objects completely different. So I'm not talking about the very same object. So I take different objects, so I control this completely independent, different value. So I'm not bound to the only very few objects, very few parameters, but I could do the complete application with separating my functionality very cleanly. So this is nice. We have 4 PDO mappings. In case of KNFT, if I assume I do this by my application, this is not the real application, it's just an example. The same is for Canopen. But here you see I use only one PDO. It's transmitted actually in a quicker time. And within one message, I can configure the whole, my whole application at once. Assuming I have logical devices within one device, and this logical device transmits only one PDO as its physical device. Still, after all the data I transmit, I still have plenty of room in PDO to transmit some diagnostics data, some information about errors and how to fix them. Imagine that. This is just an example, but this is what the future offers you if you develop 402 specification. However, we don't have this mapping as a standardized one. Well, that's it about Canopen and KNFT technology, an application example for that. Now I limit myself to the standardization, what we have, what is done actually, what we're going to do. In this case, there is a standard you can purchase. There are certain specifications such as Canopen safety and PDO mapping for synchronous and asynchronous motors, which are not standardized in IEC 61800. This is what you could use, implement, but you have to become Canopen members to access the specifications. And currently we work on a new version of 402 with new features which are not yet to disclose because to our non-members, because we don't have actually yet released them. Once we release them, we provide also press release on that, providing information in details what is new about that. And finally, we're also cooperating with IEC task force working group, which maintains the standard for drive profiles. And once we're ready, we submit it to the standardization. And in the next 5 years, maybe less, we assume we get released the new version of the standard for drive profiles. Finally, you learned a little bit of today, not only about CAN automation, but about what we do. Actually, we're working on 4.0.2. There are classic Canopen, KNFT version, and we introduce some new features, new modes, and extend existing modes. The only thing I would say that there is some extension for the torque mode, just to make you a little bit involved in those. We have additional encoder support for the drives, additional encoder. We introduced 64-bit value for actual positioning, for reading back the data, and downscaling this value to 32-bit value from an outside external encoder for processing in position value. We release soon, I hope, Canopen and KNFT profile parts for 4.0.2. They will exist independently. You could implement either part. KNFT offers certain flexibilities, but it depends on your decision. If you find Canopen's working already good for a long time, and you don't need to do any changes, do not require any bandwidth, any extremely large process data to submit among your drives, then Canopen is your friend. On the other hand, KNFT offers some certain flexibilities. So if you still have, if you have questions whatsoever, you can contact us by email. If you would like to go to other exhibitions, if you go, despite the pandemic, is not yet to the end. We are hoping to attend SPS in Nuremberg in this year, and several other key exhibitions where we present CAN automation and are ready to answer your question, not only about 4.0.2. There are further webinars available by the end of this year. You could check out them in our website and register for them. That is where you contact us. Important technical questions for 4.0.2 and other specification, please address to the service@canoncia.org. So thank you very much for hearing me. I hope that it was helpful, and you're welcome to contact us, ask questions.